Alright guys, so really quick, I'm going to do problems 4, hey, helps if I've got a pen on, 4, 5, and 6 for from the review. So I'm going to do them in reverse order, so I'm going to do 6 first, because 5's a little bit of a pain to do. So I don't want to quite get into it right yet. So right now I'm just going to do problem 6. Alright, so 6 says you pull on the 98 kilogram bag of birdseed, drag it across the deck. Coefficient of friction for the bag is 0.445. What force must you apply to move the thing at a constant speed? So basically, step 1, are we at equilibrium? The key thing being constant speed. Constant speed means zero acceleration. Zero acceleration means we are at equilibrium. So everything should add up to 0. So the sum of our forces must add up to 0. Alright, so we draw our force diagram. We've got gravity down, normal up. You're applying the force to the right, or the left, whichever direction you want to make it. And you've got friction the opposite way. Alright, so we've got our two equations in the x direction. We've got friction plus your applied force has to add up to 0. In the y direction, we've got gravity plus normal equals 0. Gravity we know, because it's 98 kilograms, is going to be negative 190, or 180, I'm sorry, because it's 98 kilograms. And because that's negative 980, that must be positive 980. Now we're looking for the force of friction. Or I'm sorry, we're looking for the applied force. So to do that, we need to know the force of friction. So if we zoom in here, remember that the force of friction equation is friction is mu times the normal force. So we know that mu is 0.445, the normal force is 980, and so your applied or your force of friction is going to be whatever that multiplies out to be, and applied force is going to be equal to that as well. Alright, so number 5. So we got mass, mass, and these loop like that. Alright, fantastic. So drawing our quick force diagrams, we got gravity down, tension up, gravity down, tension up. This block has a mass of 5, so this is going to be negative 50 down. This has a mass of 5.25, so that's going to be 52.5 down. Alright, so I'm going to redraw this problem. I'm going to say I've got a 5.25 kilogram block connected to a 5 kilogram block with 50 newtons pulling right. There we go. And 52.5 pulling left. And so this is just my simplification. I'm going to simplify it even further by saying I've got one block that's got a mass of 10.25 with 50 right and 52.5 to the left. Alright, so as always, I add up all the forces in each direction. I got 52.5 to the left plus 50 to the right is going to add up to my net force. And remember, net force we always plug into F equals ma. So I'm just going to go ahead and take this and I'm going to sub that in for my net force. So I'll take the mass of my total object times my acceleration, which if I pull up a calculator real quick, so I've got 2.5 to the left is going to be my net force, and 2.5 divided by my mass of 10.25 gives me a net acceleration of 0.24. Alright, so that's going to help me out, because if I go back to here, part B then says, what is the tension in the string? So I need to pick one block. It doesn't matter which. Let's pick this one. Alright, so I've got 50 newtons up, I've got some tension, or I've got 50 newtons down, I've got some tension up. Alright, so what I need to do here is I need to say, well, in my y direction, I've got my tension plus my gravity adds up to my net force. And then my net force in this case is just of the system. I don't care about that block. I just care about my system over here. So I take my 5 kilograms times the acceleration that block is moving to, which we just said was 0.24. And I calculate it from there. So it's going to be 5 times 0.24 plus 50, so 51.2. Alright. Sorry, 1 second. Alright. So that's 5. And then finally number 6. Number 6, sorry for putting this even on the review. It's a lot harder mathematically speaking than one I would give you on a quiz. When I was setting this up, I didn't read it carefully enough and it wasn't what I thought it was. So let's talk about 6. So we've got a rock that's 23.8 degrees, and that there is going to be 81.8. Alright, so what you've got to do here is we've got two vectors that are acting in more than one direction. So we have to split them up. So this, I'll call this T1, that's this one here, and this is T2. Now, I've got T1x, I've got T1y, and then over here, I don't know why I drew that so small, but that's going to be 81. This is T2, we have T2x, and we have T2y. Oh, I drew that whole thing in a tiny corner. You know what? That's actually that'll actually work out for us. Oh, I did the exact same thing right there. That's uncomfortable. Alright, anyway. So what we're gonna have to do here is we gotta set up write our list of equations. So we've got the x direction and we have the y direction. Alright. So in the x direction, we're gonna have T1x plus T2x, and this whole thing is at equilibrium, so it's going to equal 0. It's at equilibrium because it's not moving. It's hanging. In the y direction, we've got T1y plus T2y plus gravity, which we'll call weight, is equal to 0. Now I'm going to do x in blue, so let me mark that. X will be in blue, and we'll do y in red. Alright, so in blue, I'm just going to sub in. So T2x, really what we've got here is T1x is my adjacent. So I'm going to replace T1x with T1 cosine 23.8 degrees. And that's to the left, so I make it negative. Plus my T2x is my adjacent as well. So plus T2 cosine 81.8 degrees equals 0. Now, remember, cosines of angles are just numbers. So for the sake of making all this smaller, I'm just going to plug in the numbers. So cosine of 23, hold on. So cosine of 23.8 degrees is 0.91 T1. Should be negative. I don't know why I did that. Alright. Plus cosine of 81.8 is 0.14 T2 equals 0. And I'm just going to go ahead and do the same thing to my y, and I said I'll do that in red. So T1y is going to be the same thing but using sine, and sine of 23.8 degrees is 0.4. So I've got 0.4 T1, sorry, that's T1x. And that's to the left, so I make that negative. Minus my T2y, which is going to be sine of 81.8 degrees, which is 0.99 T2. Minus, because it's down, actually I'm sorry, these are both up. I don't know what I'm doing there. Those are both up, so I leave those positive. Plus gravity, which this thing has a mass of 12,250, so that means gravity is 1,2,250, 0. And that's all going to equal 0. Alright, so I need to pick one equation, because you should be able to do this without too much problems. The problem is now you've got two unknowns, two equations, and you have to solve this using a system of equations, which I didn't intend for you to do. But so we need to just pick one of these equations here. I'm going to choose to pick that one right there. I'll just make a new screen. Alright, so we've got, so we're just going to go the x direction. We have to solve it out for something. I'm going to pick T1. So T1, sorry. Again, if you're getting confused, just kind of ignore this. We don't have to deal with it. But we're going to have negative 0.91 T1 equals negative 0.14 T2. Alright, and so all I did there was subtracted over the T1 cosine 81.8, which is 0.14. And so what that gets me is T1 is equal to whatever negative 0.14 divided by negative 0.91 is, which is 15, 0.15 T2. And the reason that helps us is we go back to here, and we can say, alright, well, in reality, T1 is 0.15 T2. So I can say this is 0.4, and T1 is really 0.15 T2 plus 0.99 T2 minus ... all this stuff over here. Okay, so I take 0.4 times 0.15, which is 0.06. So this is 0.06 T2. I add 0.99 T2, 0.99. So I get 1.05 T2 is equal to, I'm going to add this over to both sides, 1,2,2,500. So T2, basically I just divide that out. So T2 is going to be 22,500 divided by 1.05, or 116,666. But remember, I said T2 is really, or T1 is really 0.15 T2, right? You got that over here? So if that's the case, and if T2 is 116,666 times 0.15, then T1 is equal to basically that times 0.15, or 17,500 newtons. Okay, so don't forget the steps. Step 1, are we at equilibrium? Step 2, draw a force diagram. Step 3, if you have a force at more than one direction, break it up into components. Step 4, write your equation for all your forces in the x direction, all your forces in the y direction. If you're in equilibrium in that direction, that equation equals 0. If you're not at equilibrium in that direction, that equation equals your net force. Solve for any forces you know, plug in, solve for anything you don't know. If you need to solve for acceleration, take your net force, plug it into F equals ma. I'll be in early in the morning if you guys have any questions, or shoot me a text. Good luck.